Hello everyone, myself Guru Joshi. Today we are going to discuss a topic named trigonometric function. So let's start with the first topic, that is hyperbolic functions. The hyperbolic functions are defined as sin hx is equal to e raised to x minus e raised to minus x upon 2. We are writing this hyperbolic function in the terms of exponential. Okay. Now cos hx is e raised to x plus e raised to minus x upon 2. So when we are writing sin hx, minus sign will come. Okay. And for cos hx here, plus sign will come. Now using these two, we'll find the rest of the functions. So tan hx. Okay. Now we know that tan hx is what? Sin hx upon cos hx, right? So divide these two, so 2 will get cancelled. Okay, so what we have is e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x. Next is cot hx. Now cot hx is 1 upon tan hx. Okay, so tan hx is this reverse, so we have e raised to x plus e raised to minus x upon e raised to x minus e raised to minus x. Next is sec hx. Now sec hx is what? 1 upon cos hx. Alright. So just reverse this. So we have 2 upon e raised to x plus e raised to minus x. And at last cosec hx is what? 1 upon sin hx. Okay. So we have 2 upon e raised to x minus e raised to minus x. Okay. So we need to remember this two formula and we can write all these terms. Okay, now let's start with the example. Show that cos hx minus sin hx is equal to e raised to minus x. So let's start with the RHS. So we have cos hx minus sin hx. Now we know cos hx is e raised to x plus e raised to minus x upon 2 minus sin hx is e raised to x minus e raised to minus x upon 2. Okay, so this is upon 2 here, e raised to x plus e raised to minus x minus e raised to x and minus minus plus, so we have e raised to minus x. Now these two will get cancelled. Okay, so what we have, 2 e raised to minus x upon 2 and therefore e raised to minus x, and this is your RHS. Okay, so we have proved this result. Now let's move to the next example. We have to prove that cos hx minus y is equal to cos hx into cos hy minus sin hx into sin hy. Okay, now we will prove this result from RHS. Okay, so RHS is given to us, that is cos hx cos hy minus sin hx sin hy. Okay, now we'll write down the formula. So cos hx is e raised to x plus e raised to minus x upon 2, okay, into here e raised to y plus e raised to minus y upon 2 minus, now sin hx is e raised to x minus e raised to minus x upon 2 and sin hy is e raised to y minus e raised to minus y upon 2. Okay, now we'll take out 1 upon 4 common. Okay, and now we'll multiply these two terms. Okay, so first we'll multiply this e raised to x with these two terms, so you will get e raised to x plus y. Okay, plus e raised to, now e raised to x with this term, so we have e raised to x minus y. Next we'll multiply this e raised to minus x with this two terms, so you will get e raised to, we'll also take out minus common, so we have x minus y. Okay, and plus e raised to, again take out minus common, so we have x plus y. Okay, now we have negative sign over here. Now multiply this two term, so what you will get, e raised to x plus y, okay, minus e raised to x minus y. Okay, now minus sign we have over here, so this is minus e raised to minus common, so x minus y. Okay, and this minus will give you plus, again take out minus common, so we have e raised to minus x plus y. Okay, Now open the bracket. Okay, so if you will open the bracket, this two term will get cancelled, right? And this two term will get cancelled. Okay, what remains is e raised to x minus y and minus minus plus. Okay, so we have 2 times e raised to x minus y, and again this minus and minus will become plus, so we have 2 times e raised to minus x minus y. Okay, take out 2 common and it will get cancelled, so we have e raised to x minus y plus e raised to minus x minus y upon 2, and this is the formula for cos h x minus y, which is our LHS, right? So we have proved this result. Now let's move to the next topic, that is inverse trigonometric functions. Okay, so now we'll discuss the domain and range of the trigonometric functions. So for sine inverse x, the domain is closed interval minus 1 to 1 and range is from closed interval minus pi by 2 to pi by 2. For cos inverse x, the domain is minus 1 to 1, okay, and the range is closed interval 0 to pi. For tan inverse x, the domain is R and the range is closed interval minus pi by 2 to pi by 2. Okay. Then for cot inverse x, the domain is R and the range is closed interval 0 to pi. For sec inverse x, the domain is R minus minus 1 to 1, okay, and the range is closed interval 0 to pi minus pi by 2. And for cosec inverse x, we have domain R minus minus 1 to 1 and the range is from minus pi by 2 minus 0. Okay, now we have to remember the domain and range of this trigonometric functions. Okay, now let's see some formulas. So sine inverse minus x will give you minus sine inverse x with the condition that mod x is less or equal to 1, means the value of x should be between minus 1 to 1. In this condition, we have sine inverse of minus x as minus sine inverse x. Then cos inverse minus x is pi minus cos inverse x, again provided that mod x less or equal to 1. Tan inverse minus x is equal to minus tan inverse x, where x belongs to R. Cot inverse of minus x is pi minus cot inverse x, provided x belongs to R. And cosec inverse of minus x is minus cosec inverse x with the condition mod x greater or equal to 1, and sec inverse minus x is pi minus sec inverse x with the condition mod x greater or equal to 1. Okay, so we have to remember all this. Now let's say some more formula. So sine inverse x plus cos inverse x is pi by 2 for mod x less or equal to 1. Then cosec inverse x plus sec inverse x is pi by 2 for mod x greater or equal to 1, and tan inverse x plus cot inverse x is pi by 2 for x belongs to R. Okay, so these three are the important identity which we have to remember. The next is tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus xy if xy is less than 1. Then tan inverse x plus tan inverse y is pi plus tan inverse x plus y upon 1 minus xy if xy is greater than 1, and for xy equals to 1, tan inverse x plus tan inverse y is pi by 2. Okay, now tan inverse x minus tan inverse y is tan inverse x minus y upon 1 plus xy. Okay, so we have to remember all this also. Now let's move to the next topic, that is laws of sine and cosine. So first one is the sine rule. So consider a triangle ABC, okay, and this small b is equal to AC, small a is equal to BC, and small c is equal to AB. Okay, so we are denoting this AC by small b, okay, this AB by small c, and this BC by small a. Okay, and now we'll write down sine rule and cosine rule. So the sine rule is a upon sine A is equal to B upon sine B is equal to C upon sine C. And the cosine rule is E square is equal to B square plus C square minus 2 2bc cos A. B square is A square plus C square minus 2AC cos B, and C square is A square plus B square minus 2AB cos C. Okay, so you have to remember the sine and cosine rule in order to solve example. Now, let's start with the example. In triangle ABC, B is given 21 degree, C is 46 degree, and AB is given 9 centimeter. Okay, so here B is given, that is 21 degree. Okay, C is given 46 degree, right? Then AB is given, that is 9 centimeter. Okay, and we have to solve this triangle, means we have to find this capital A, okay, and this small a and small b. All right, so we know that the sum of all the angle is 180, so a plus b plus c is 180. Therefore a is what? 180 minus b minus c, and it is 21 and 46. Substitute, so you will get the answer of a as 113 degree. Now we'll use the sine rule to find the values of a and b. So the sine rule is a upon sine a is equal to b upon sine b is equal to c upon sine c. Keep a b as it is. Okay, in place of a we'll write 113 degree, in place of this capital B we'll write 21 degree, and this is 46 degree. Okay, c is given to us, that is 9, so we'll write over here. Now to find b, we'll compare these two terms. Okay, so b upon sine 21 degree is equal to 9 upon sine 46 degree. Using the calculator you can find the value of b, which you will get as 4.484 centimeter. Okay, now we'll compare this first and the last term to get the value of small a. So a upon sine 113 degree is equal to 9 upon sine 46 degree. Okay, again using the calculator you can get the value of a as 11.517. Alright, now let's solve one more example. In triangle ABC, okay, AB is given to you, that is 42 centimeter. Okay, BC is given, that is 37. Okay, this is 37 given, and AC is given 26. Okay, we have to solve these triangles, means we need to find all the angles. Now it is given in the question AB, BC and AC. Okay, now we know by the notation that AB is small c, so small c is 42. Okay, small a is 37 and small b is 26. Now when we use the cosine rule to find the angles, so the cosine rule is a square is equal to b square plus c square minus 2bc cos a. Now we know the values of a, b and c. Okay, substitute it over here. Okay, and using the calculator we can find cos a as 0.4904. Okay, so a is cos inverse 0.4904, so you will get answer as 60.63 degree. Okay, similarly using the other two identities we can find the value of b and c. Okay, the answer of b and c is mentioned over here. You can solve and verify your answer. Alright, so I hope you have understood throughout the session. Thank you for watching.